Again, how's everyone today?
Good. How are you?
Doing well. It's cold out there. At least it's somewhat warm in here. Um, so,
Yep. I heard it snowed in some parts of Scottsdale.
really,
Yeah, I think so.
I saw the snow over in LA. I'm glad we're not there. Yeah, it feels cold enough. Anyway, so just an update. We're here. This is Thursday. We're here to take a look at Chapter 5, and this is, uh, I've been told by students, and I think it's one of the most important sections we start into, financial math. So today we're going to talk about savings plans and basically, how do you, I'll call it get rich slowly, but we can all be millionaires if we follow a plan. Next week, we get into the math of loans. So that's also part of it, is when to borrow and what's those costs. The good news is the mathematics behind both of these two sections is pretty much the same. There's some money that somebody will be paying some interest on, because money has a value. If you put it out there, someone needs money. If you need money today, you will pay interest on it so you can have it. Somebody else needs it, they will pay you back with interest. So money has value in itself for what it can buy, but it also has a time value. And that's what we're going to. What's that?
It can also decrease.
It can, right. So sometimes you invest in something, and if that investment doesn't go well, that's an important thing to remember.
A savings account for a few years, it's gonna drop for sure.
And because of something called inflation, money is actually losing its value. So all those things we'll talk about. And so the thing is there's no one right way to do things, but you just got to make your best choice. So anyway, from these two sections, you get an idea of how to set yourself up, what you do. And also it's a field I used to work in. I was in financial planning for about 13 years. So I did mortgage loans, I did life insurance, health insurance, retirement plans. I was the inside guy. I wasn't a real good salesperson, but I could make the proposals for them, and I could manage all that kind of stuff. So, and I invested in some things where I bought high and sold low, which is not what you're supposed to do, right? That's when you lose the money, but hey, it happens. So anyway, we've got those two coming up, and we got a spring break. Now, I'm going to be out of town next Tuesday. I'm presenting at a conference that's a spring break at ASU, and I haven't been able to find anyone to fill in. So I'm proposing what we do is we just don't meet next week for the lab day. If you need help, email me. We can maybe touch base through Zoom or something. But what we'll do is today's lesson will probably be only about 45 minutes, so we'll get a chance to start into things. And then next Thursday, it's a fairly brief presentation. It's just the money's going the other way. So in savings, we give somebody our money and they give us back the interest. Borrowing, it's the same mathematics, but the money's going in a different direction. They give us the money.
For chapter 6, will even be any homework because the following week will be spring break?
Well,
I guess kind of answers its own question.
yeah, there's still got to be homework.
A big NO.
Yes, there'll still be homework. Still be stuff to get
Wait,
through.
what?
Of course, there'll still be homework.
Oh, because next week's feels a little bit of the spring break.
Yeah, and you can choose to do it over there, or you can wait, but get it done by the next week, because then, when we come back from spring break, we'll do a day of review on Tuesday, and then we'll actually have the midterm on the Thursday.
For the review, is there going to be like a practice test?
There will, and I'll have that for you next week.
Oh, okay. Would the practice test be similar to the actual test?
It'll be the similar content, yes.
Okay.
Yes, so it'll help you prepare. So if you do well on the practice tests, that's the idea, is that you will do well on the actual test. The test itself is a paper version. It's multiple choice. So we give you all the answers. You just have to pick the right one out of a lineup of 4 or 5 questions or answers. So we give you a bunch of wrong ones too. But I always say, the answers are all there.
We don't need to bring a laptop.
You don't need, you wouldn't need to bring a laptop. You do get to use a page of notes front and back. And I say, what's a page? Well, I had one student take me up on this. There's no size limit, so do what you need to do. So don't worry about trying to get a postage stamp and put it all on there, or even if you need a little bit larger site, go ahead and make one. But you get notes. Okay, so as you do the review, keep notes of what you've been doing, any formulas you might need, or directions on how to use. Except now, I'll back up. You might need a laptop if you want to use some of these apps that I'm going to show you. Although you can use your phone with them, and so I'll allow you to use your phone even though they have internet access. But if you download them to your phone or a tablet, you can use them. You can use a laptop if you want, because a lot of what I'm showing you is electronic apps rather than a calculator, handheld calculator. Any questions? All right. So let's get into it. And I've posted this because what I've done is I've moved all the due dates, and I think I'll push them out on the other side of spring break to the review. So anything you haven't finished, you can finish those up. And that'll be helpful. So we're in week 6. So the materials we have here, there's the financial presentation. We're going to go through that. I'm supposed to have some links here to a calculator. Let me add that into the course real quick. So I just do a search on financial calculators, and it's actually calculator.net. It always comes up pretty quick. TVM calculator, I like this one. I think this is the one I use. Is this the one I want to use? No, this, sometimes they change things. Maybe it's this one. Yeah, this is the one I use. So I'm gonna copy this link and put it into Canvas. And this will be helpful for both Chapter 5 and Chapter 6. External URL. So we'll use this a little bit later. Most of the presentation today will be mostly principles about financial math, and then we'll get into the quiz where we'll actually work through some problems. Okay, so we'll define everything, and then we're going to be using this financial calculator. So I'm going to leave it open here. The same thing if you go to the App Store either.
Were you able to get the laptops working
Um,
consistently?
they're gone, so maybe not. They had to take them down to the IT. Yes.
My question is, on the midterm, are we gonna be able to use like financial calculator and like different stuff on the internet to help us?
Yes.
Oh, okay, cool. And is it gonna be like online, the midterm?
It will be paper.
Oh, it'll be paper, it's
Yeah.
just you could use your computer
Right.
or phone to look stuff up?
Exactly.
Gotcha.
So, and I'll provide these links. I'll provide a page that has all the different links we've used to Desmos, to this calculator, and this one also, as you see over here, has a lot of different calculators. This is a great one. I've got it on my phone. You can download it as a phone app. It's got a conversion calculator on here. It's got all sorts of calculators, but it's really powerful to have on your phone if you're going to use it. Okay, so let's
Also, I have another question about like homework in general.
Okay.
So it's due on Tuesdays. It due Tuesday at like right before midnight, or is it just due on Tuesday like by midnight of Tuesday?
It should say in there, but usually I do it 11:59, so you have the full day to submit them. If you need more,
Okay, so on Tuesday it can be at 11:59 on Tuesday.
yeah, I wouldn't wait till
Yeah, I
11:58 to
wouldn't.
get started on it,
I
but
wouldn't wait either, and I already got started on it, but I was just asking because that's just something that's good to know.
yeah, yeah. So, okay. There we go. So that's going to work out better. So first is when we talk about the math of savings, of money, there's a few things we'll go over. We're going to look at how to take control of your finances first. We're going to look at compounding. That's where the math really enters in. And then we'll look at savings plans. Next Thursday, we'll look at loans. And those are kind of our two things that we do. So taking control of your finances. Yes.
The one more thing is I just looked and saw that chapter 4 is due March 21st. You
Mhm.
extended a second time?
I did.
Oh, okay, I didn't even notice.
Yeah. So that's again, my goal is that you don't get cut off. So actually everything is extended, I think, until at least spring break, and probably my goal was to make them like Tuesday. So get them, the sooner you get them done, of course, the better, but get them done. And then so that we can focus on, when we get back from spring break, that review test, the practice test. Go through that, and then we'll actually take the midterm here in class on Thursday, paper version. But again, yes, you do get all your access. And hopefully we'll have some backup, because the little cart that was up there is filled with laptops. They just wouldn't log on. So they're working on that, and we'll have them, so you'll have access. Okay? So first of all, and again, this is a little bit older. It talks about checks and written checks. I mean, I can't remember how many do you ever write a paper check anymore? Occasionally, but usually, sometimes we get paper checks, we deposit them, but a lot of times there's payment apps, and some countries it's actually more. Like in Thailand, they've got all those QR codes. You click on it and you transfer money from your bank account. You never need a check. Almost don't even need money anymore. But what you want to do is, how much money do you have? Keep track of what you've got. Keep track of what you spend. And again, with credit cards and stuff, where there's, you're basically taking a loan out every time you do buy something. Sometimes it's easy to spend more than you might have intended to spend. And then finally, don't buy on impulse. And sometimes it's good therapy. Hey, I feel bad today. I go buy something and feel good about and it does. You get that good feeling, but then the bill comes due and you got to pay it. But so again, we're going to talk about budgets. And if you know that some days it feels good to go out and buy something completely frivolous, put that in the budget, and then it's okay. Okay, so that's the budget part. So 4-step budget is list all your income. If you've got a job, how much is coming in, if whatever source that is. If you got financial aid, list all of that stuff. But sometimes, like with financial aid, you get it at the beginning of a semester, but it's supposed to last you the whole semester, right? So make sure things get listed out on a monthly basis. You might have monthly expenses, rent, gas, whatever those are. Kind of list those out so you know what you're going to have to spend. There's also ones that you got to be careful about. Sometimes you have like something that only comes up every 6 months or maybe once a year. You want to be prepared, so be saving so that, I got $1,000 bill this month and it's going to cover something for a whole year. You should hopefully be budgeting about $100 a month before that. So at least be ready for any types of expenses that are going to come up. And then we subtract the expenses from the income. This is what we call cash flow. If it's negative, if your cash flow is negative, what does that mean? Negative cash flow. You've overspent, and so then you got to go find some money, or you got to cut what you're spending. So, and again, if you do it in advance when you're making your budget, you figure it out before it's a problem, and you solve the problem early on. If you wait till it is a problem, oh, I need $50 to put gas in, but I spend everything. I don't even have money for gas anymore. Then that's what it is. So make adjustments as needed. Okay, so just kind of be, and again, I typically when I do this, I'll get a new step, I'll set up the spreadsheet, I'll get it all set up. Once I get it working, I stop doing it as much, and then I find I might have problems again, because it's always more fun to overspend than not. But it's never fun to be out of cash and owing cash to somebody. So anyway, we're going to talk about how savings works, because that's sort of our long-term thing. And what you're going to see is what I call retirement is being able to live off of what you've already saved for yourself or whatever, so that you don't have to have a job. It doesn't mean that you aren't working, but you get to work in what you want to do. Of course, you may have a different idea of what retirement is. It may be playing golf or watching The Price is Right all day long, like I know some of my friends do, or maybe being able to go to the islands and sit on the beach, and whatever it is, maybe working for a nonprofit and doing things. Anyway, we're going to talk about that. Next week we talk about the mathematics of loan, because that oftentimes, if you get a job, you need a car today, right? If you don't have, most of us don't have money. If you need a house, we'll talk about house loans, so taking loans is a part of finances. While taxes are also part of things in planning, we don't get into that personally, but it's something to take in consideration, especially once you start working full-time. There's ways that you can set up your tax situation, like generally buying a house, you get some tax deductions, putting things away in a certain way, you pay fewer taxes, and so then that helps out. And then as students, federal budget affects you as far as financial aid, maybe all that kind of stuff. But again, we won't get specifically into that, but sometimes what the government does makes a difference. I have a link in Canvas to this particular book. This was a book that my first boss that cared about me, I guess, gave to me when I was in financial planning. It's called The Richest Man in Babylon. It's a story written by a financial planners in the 1920s about a guy in ancient Babylon who basically came out of the desert with nothing, was a laborer, but was able to save his way, and has sort of got a plan of how to save your way and how everyone can be rich. And basically he put on little courses for people, for his fellow worker bricklayers and stuff, as they built that city, of what you do to save money. And we'll talk a little bit about that, because that's kind of what we're getting towards. What we're going to be using is this, actually I've got to get another calculator. There's also an online thing for a simple calculator. We can use algebra for it, because there is a, I forgot, this one has a different tool. There's a fairly simple equation for something called simple interest. And simple interest is you loan somebody some money and they pay you back just interest, but they don't compound. You don't get interest on top of your interest. You just get the interest back. So some of the problems we're going to work through will say that it is simple interest. Okay, so as we go through the homework, we'll make a distinction. if it just says interest, we're going to use compound interest. We'll use that compound interest calculator that I showed you. If not, you'll want to use the simple interest calculator. And I'll get a link to this one because it's pretty helpful. We'll get that when we start going through the homework, and I'll show you how to use it. I don't think this is I haven't found one where you can download to the phone because we typically don't use simple interest, okay? But there is this equation here, and mostly what we do is need to find out what these letters are. So A is your accrued amount, so that's the total that you will get back. Say you give somebody some money, they're going to pay you back interest plus your money. So that's what the A part of the equation is. P is the principal amount, so that's how much you have saved. That's how much you're getting interest on. There's an amount of interest earned that they get, and that's determined by the interest rate. And we've been doing this, so say you're getting 5%, so if you take 0.05 and you're getting that interest for 5 years, 0.05 times 5, and inside this formula there's a 1, right? A is your principal, 1 plus RT. Does anyone remember what this 1 represents from what we were doing with the with exponential growth and percentages?
The principal.
It's the principal. That's really 1 for 100%. That's the money. And again, in this system, you're supposed to get it all back, right? You're not supposed to lose any money. So that 1 is saying you're going to get all of your principal back, plus you're getting interest. Again, I guess the interest could be negative. That's how we could lose some money, but hopefully our interest is going to be positive. Okay, so R is an interest rate.
Oh, so it's RT, so it's 1 plus R times T, right?
Correct. Right, so that's up here. So R is your interest rate, and that will be a annual rate, so over a year. And T is your time in years. And again, we'll work through a few problems, but if you use the online calculator, a lot of this you just have to enter the things where they ask for it. They have a place for the principal, they have a place for the rate, and they have the place for the time, and it will calculate for you. Okay. So that's simple interest. Again, in the modern world, we don't use it a lot. We use mostly compound interest. And so this is a picture of how we're going to do it. What these are called, if you have a TI-84 calculator or a financial calculator, a lot of times they have something very similar to this built in. You'll see that there's always something called the present value. That's the money you have today. When we're saving, if we have a chunk of money that we have saved, that's what the present value is. There is also, since there's a present value, there's also the future value. So that's that money that you'll have in the future. And so that's that time value. Okay, we've got a starting date and an ending date, and hopefully what we're going to talk about is ways to see that money grow. Another item that may be is we could also add regular payments. Like we could save on a monthly basis, put an extra $100 in, whatever. So that's part of the formulas. I'm going to show you the formulas just so you can get an idea of how it all works. But again, when we go to actually do the homework and stuff, we're going to use this time value of money. That's what TVM stands for, a calculator. Okay. There's the annual interest rate, and you can actually change the way it's compounded. We'll talk about that is how often do they pay you your interest. If they pay it only annually, that's annual. Sometimes you get your interest paid to you monthly. And then what you start doing is each time it gets paid to you, now you get interest on top of your interest. So that we're going to see how that works. And then the periods down here is for how often the payments are made. and the compounding here. So these all, and we'll talk about, they'll all match up, but compounding periods are typically going to be monthly. They could be daily, they could be something else, but we'll look at those questions. But basically, the way this works is we will be given all this information except there'll be one thing that's missing. That's the question. They might ask, what is the future value of this situation? We plug in all the numbers and then we click on FV and we get our answer. Or they might say, we need to save $50,000 and we're going to do this, that, and that. How much do we need to put in? So we might put everything in, and we might have to click on the present value to see what we would need to deposit to make that happen. Okay, so whatever the question is going to be one of these buttons. Everything else, we're going to be able to fill in with numbers from the question. And the goal is that we're going to give you some questions that help you understand how savings plans work. Okay, so here's a formula. And again, you don't have to memorize this. We're not going to have you use it. When I teach over at ASU, they don't give you the financial calculators. You have to use these formulas. So I says, financial planners, we don't use formulas, we use calculators. But what I want you to think about is what's going on here. So this is our present value. So this is the money we have saved. What happens to it? We get 100% of it back. That's what that 1 stands for. We're getting plus the interest. And when we have compounding, we get the time is up in the exponent. Now we talked about simple interest, right, being multiplied by the time. So if I take 3 times 4, what do I get? 12. So that's just simple math. But if I take 3 and I raise it to the 4th power, looks very similar, but it's, what am I going to get? 3 times 3 is 9, times 3 more is 27, times 3 more,
81.
Very good. Which one gives us a bigger result? Multiplication or exponents?
Exponent.
Extremely bigger. So what you're going to see is that one of the things that we understand from this formula is the more time you allow, because time is in the exponent, it has a big power. So if you have 10 years to save, that's better than having 5 years, and it can make an extremely different. And 20 years to save, so the more time you have, we're going to see the more you're going to, it just becomes much bigger. Okay, but it does take time. Some people think, oh, I'm going to save today and next year I'm going to be a millionaire. Not really. But if you follow this plan, maybe 20 to 30 years you'll be a millionaire with a smaller percentage. Okay, so again, these lay out all the things that these are. Future value is what we're going to have at the end of some time period, right? And these all are we're going to enter into that online calculator, and it will calculate the missing part. So we're not going to have to do algebra. We're not going to have to mess around with formulas. It will handle it most, but we do have to understand how it works.
Oh,
Yes, sir.
just curious, have you been sticking to the plan?
For a while, I've blown it 3 or 4 times. I've retired retired from Oregon State. I used all that money. I retired from this one. I bought a house. So I'm on my 3rd retirement, which means I'm going to be working till I'm 80. But the main thing is I found a job I love to do, and I'm happy to work till I'm 80 teaching. This is especially with you guys. Like I said, I'm over at ASU. I got 150 students. It feels more like work, and it's kind of like we just don't get to connect. But here, community college, which I'm looking to get back into, I love what I do. So that's the most important thing is as you're making the best investment right now into yourself, figuring out what you want to do with your life, getting that thing that you want to do that you enjoy. I mean, sometimes work is work, but if you at least like what you're doing, then everything else will work, okay, because you'll have the time you want. Actually, when I was in financial planning, I just was working to get retired. I was hoping to retire by 45. My plan wasn't, it didn't work out. But that's okay, because I was so stressed I wanted to get out of it. What I did is I changed careers, and now I'm not so worried about getting out of it. Okay, so here's what happens when we compound. So if you take out if you put some money into savings and you get annual compounding at 8%, you get basically 8% back. But if you get paid that interest early, so quarterly, so if they pay you 4 times a year, it's like getting 8.24%. So you're getting an extra interest because you're getting interest on the interest. So that's what this calculation says. And what you'll see is that the more times it happens, so if they pay it 12 times in a year, which is monthly, right? That's almost 8.3%. So you're getting more interest. If they do it every day, it's 8.32. So there is a limit. It's not like if they did it, what's this? It's 10 million. If they did it 1 billion times a year, like every second, it's still, the most you get is about 8.3%. Okay, so there's a limit, but what you want to do is you want to get some compounding. You want to have something where you're getting things hopefully monthly, and then you're fine. But there are plans that will, like credit cards, they actually charge you daily interest, right? Because that's what they're trying to get as much as they can. But so savings plans and investments. Again, it's getting more complicated, but we're not going to use these. This is if you had a payment instead of having a lump sum of money to put away. So you've got your payment, but look at it's getting multiplied by some number. But what's in the exponent? Oops, let's back up. What's in the exponent? Y.
So payment periods and times years.
It's yes, and the years are up in the exponent. So what you're finding is when you have a savings plan, the more years you give yourself, the greater the
Now again,
value is going to be.
obviously this is more of an explanation because of how complicated this actual equation looks. Most of the actual stuff is we plug in values into the calculator.
Right. Yeah. It's getting a higher interest rate makes a difference, and we'll see from the problems. But the one that's going to make the bigger difference is the number of years you leave it on deposit, because each time you get another exponent, as we saw going 3 to the 4th power, we got to 81 instead of 12 when you were just multiplying. So that exponent does it. So that's all I want you to really understand. And again, from the formulas, they define what they have, the same things. You've got a present value. A lot of savings plans, we don't start with anything. We start with monthly payments, right? Or monthly savings. So sometimes the present value is 0. Sometimes we start with something, okay? Future value is what we're going to have eventually. Interest rate, number of years. Anyway, every question we have, we'll know everything except for one thing. And that the one thing we don't know is the question. We'll put in everything else in the calculator and then be able to solve for the part that's missing. Okay, this is if we had some money to start with and a payment. So you see how the formulas get really complicated, and this is why financial planners, they use financial calculators, because it's all built in.
Mm-hmm.
It's all handling it, and then you just focus on these details here of what your future value, what that might be a goal, or what you're trying to save this much for retirement, present value, how much you can put down, all those kind of things. Okay. This is one formula that will be helpful, and actually if you from our percentage section, you might recognize this. This is what we call the total return, and it will give us a percentage if we multiply it by 100, because it's actually going to give us a decimal. And for those of you, we talked about this as percent change. So future value, that's something that's happening in the future. When we were doing this with percent change, we called it the new. The present value, that's either today or it's what we deposited. That was the old amount. And again, these are all relative. divided by the old. Anyone remember this?
I do, yeah, that was from the,
So it's the same formula. It's really just percent change. It's the future value minus the present value divided by the present value will tell us how much we've earned on a total, as far as a total return. We're going to see though what's missing from this equation. We've got future value, we've got present value, but what don't we have? We talk about we're using a time value of money calculator. Is there any time in this equation?
no.
There is not. So it's not real helpful, but there are programs and investments that will talk about their total return. What you really want to get to is what is your annual return, because that's what we can compare. If I have a 50% total return, I don't know if that's good or bad, because that might have taken 100 years to make it happen. If 50% in 1 year, that's a good return. So we're also going to see that there's something called annual return, which is actually much more important for comparing things. So here, and we'll see how this works. It's 2004, you invested $27,500 in a piece of land. 2013, it was sold for $43,400. What would be the total return? We take the new, which is the sales price minus the purchase price, or the old, right, divided by this, and it does come up with a 57.8% return. And you might be thinking that sounds pretty good, but that was over how many years? 2004 to about 10 or 9?
9.
9 years. So you could divide that by 9 and sort of average it out, but again, it doesn't quite work that way. If we want annual return, this is again another formula that you may want to write down, or again, you have access to these, but this will be a formula that we'll use as well. Notice it's the future value divided by the present value, so that's a real easy thing. And then we raise it to the power of 1 divided by the number of years. Okay, so this takes in the fact, so we're sort of dividing by the number of years, right? But that's going up in the exponent. And then what you're doing is you're subtracting 1 because that was the original amount. Okay, it tells you whether you lost. But anyway, this will give us an annual return. And we're going to do those same numbers, and we're going to see that one that was 57% total return. We're going to see what that is actually on an annual basis by using this formula. Okay, so same question, but what's the annual return? And again, we'll click and that'll move this little thing away, or move this up here. So we take the new value divided by the old, future value divided by, and then we raise it to the 1/9 power because there was 9 years. Subtract 1 from it, and when you do that whole calculation, it's a 5.2%. It's still positive, which means we're getting something, but 5% a year doesn't sound as extraordinary as 57%, right? But they're both accurate, but one's a total return, this is an annual return. And again, if I was comparing investments, I would use the annual return. And real estate, actually, if you can get a 4 to 5% return, that's pretty good with real estate, and then now we're just going to talk a little bit about types of investments. So again, this is not anything that's going to be on the test, but it's what you want to consider. Stock investments, what you're doing is you're buying a portion of a company. So when you buy a piece of stock, and you can do it for sometimes as little as pennies, but I don't know, Microsoft is $300 a share. I haven't looked, but some companies cost more and stuff, and that's kind of, you buy 1 share. That gives you the right to, you're actually owner of the company. And my dad's worked for a trucking company called Consolidated Freightways. Have you guys heard of it? I don't know, out in Oregon, it was a trucking company anyway.
I've heard of it.
I worked for them, and part of what I got, because it was a union job, I worked, I guess, enough, I actually earned a piece of stock. So I had 1 share of stock in the company. And what was cool is they'll actually send you, when they want to make decisions, you actually get a vote. So they'd send it to me. I could
Oh,
vote.
that's cool.
Of course, it wasn't a very big vote. It was one share out of probably millions of shares. But anyway, you actually own you own part of that company, and the more shares you own, that's, and basically in corporate America, if you own 51% of a company, that gives you the right to control it, because you have 51% of the votes. The thing with stocks is if the company loses value, your investment could lose value. And if they go bankrupt, you could, and I had some friends who, she worked for a savings and, I guess they call them credit unions now. It was a savings and loan that went bankrupt. And she worked for them, she lost her job. Her retirement was all in the company stock. Company stock became worthless. So she got hit multiple ways. Bonds, these are another type of investment, but these are actually loans to the company. So they will pay an interest rate back, and you have a little bit of protection. If the company goes bankrupt, you could still sue them, and because they still owe you money, right? So but you can't vote for the company because you don't own the company, you've just loaned them some money. Okay, so that's another way. And then last one is cash. These are like banks have these certificates of deposit where your cash is there, you can take it out. Usually they pay lower interest rates. Sometimes they have a time set, you have to leave it there for so many months to get the interest, but it makes them more liquid. Okay, so when we talk about investments, there's risk involved. Stocks have the most risk because you're investing into that company, and again, you can make the most, but you can also lose the most. Bonds is a little less risky because you've got basically a contract. They'll pay you so much interest, but you could still, if they don't have the ability to pay you back, you still could lose some of your money. Cash investments, again, they have the least amount of risk. There is risk there still, but usually they're backed by the bank, and as long as you don't go over a certain amount, it used to be $250,000, they have insurance protection as well. And the full, the credit worthiness of the U.S. government, or whichever country you're in. But again, money can lose value as we go through. So liquidity, how fast can you get your money back? So some investments, you buy a piece of land, you can't get your money out of it until you sell it. That could take weeks, months, days, we don't know.
Wait.
But liquidity. Yes, sir.
Oh, sorry, I didn't mean to cut you off. Would house be an example of a liquidity?
It has less liquidity because, yes, you have to sell it.
Yeah.
Whereas stocks, it can take 2 or 3 days to get them sold, so it's not like you can get it. You've got money in the bank, you can go and you can go to an ATM right now and get cash out, right? Very liquid. So there's this liquidity is if you really need it. And again, you'll find that the less liquid it is, sometimes the more you can get. There is risk involved. Again, you buy a house, values can go up, they can also go down, so there's potential of loss. But again, guaranteed income, guaranteed oftentimes have very low guarantees. And one of the things that if you invest in guaranteed stuff, oftentimes inflation will get to you and your money's not as much. And then finally, your return. Okay, what do you get back? We'd like to get good interest rates, but we've got to balance all these things. And when you invest, you've got to be ready for it, because if you invest in a very risky stock, but you don't really you're not really good with risk, you're going to lose your sleep, and you may, if the money goes down, you're going to want to sell and get out of it right away, whereas maybe you should have held on and it comes back. So you've got to match all these things when you're doing your investments. And here's stock market trends over a long period of time, and it just shows, yes, they can go up incredibly, but there can be times when there are extreme drops. When I was doing financial planning, we looked at it, what we did is we did a 20-year rolling average. So if you left your money in the stock market for any 20-year period, you would average about a 12% return. Okay, so that's that time value if you can leave it in there. Now, even in some of these periods, you would have had maybe some years where you had some severe losses because it dropped. But if you left it in over, again, at least a 20-year period, you would come out ahead. And I think we're in one of those right now where with COVID hit, there's been some rocky times. But for those who stayed invested, there were times when they lost a lot of value, but they'd come back. And I was watching it last year. As of December, it was like a 20% loss on stock market, 20 to 25%. This first part of the year has reversed that if you now look back over that last year, it's a 20% gain. So it can happen, but you just, again, you want to get some advice, you want to get some education for yourself as you invest. Now, I've got a special treat. I'm going to introduce you to two of my favorite students that I had a few years back here at Scottsdale Community College. They graduated, they got jobs together. They were real tight in class, so they got jobs, same job, but this is going to be the story about one of them started saving right away when they started working. The other one put it off a little bit, and we're going to see which one ended up coming out. So here's my two students, the story of two twins, Tweedledee and Tweedledum. Okay, they're not really my students, but made it sound a little bit better. Got your attention, right?
Yeah.
Okay.
And I was also thinking, why would you expose the financial situations of your two students?
Exactly. So yeah.
I was thinking, is he really going to?
So anyway, Tweedledee and Tweedledum, they got jobs together. They both were paid $40,000 a year, which is not a bad starting job. Tweedledee decided, I'm going to listen to Little Crow and put about 10%. That's, if you read that book I suggest, The Richest Man in Babylon, one of the things is that your savings should be about 10%. Live off of about 70%. 20% should go to debt if you have any debt. 10% should go to long-term savings. If you don't have debt, maybe you could put 30%. You could even do better. But anyway, so 10%, he's saving $4,000 a year. I think I've got it at about 8%. So then at the end of the year, he's also got interest. So it's $4,000 he put away, but he's got $320 of interest. So at age 25, that happened. Over 10 years, his savings balance is now $66,000. His friend, Tweedledum, having a good time spending that money, but nothing to show for it, right? So Tweedledee and Tweedledum, they said, oh, let's play a little game. Tweedledum says, hey, you stop savings and I'll save for the next 10 and I'll bet you I can catch you up. So do you think so Tweedledee's going to stop for 10 years. Tweedledum is going to put in for 10 years, again, at a higher salary, right? Because now they're good workers, they're getting a raise. Do you think Tweedledum will catch Tweedledee in 10 years?
Possibly.
Possibly? Yeah?
Yeah, I feel like part of the reason is I'm guessing that since Tweedledee is going to stop saving and just spend, and he's going to lose a lot of money too, so Tweedledum's going to end up catching up.
Let's see. Tweedledee doesn't use his retirement savings. He left that $66,000.
Oh.
So that's going to keep growing, and look what happened. Tweedledum, now, yeah, he's probably spending, instead of saving the money, he gets to spend that money. But Tweedledum has to put all this money away.
Oh, I see.
And he still, after 10 years, is only halfway there. This is just Tweedledee living off the first 10 years of savings. Okay. Well, another 10 years. Do you think Tweedledum will be able to catch him up? Okay, now you're catching on.
No.
No.
Maybe.
So we'll put it out. Here's 20 years down the right. Tweedledee has not put anything in 20 years. They put in for the first 10, nothing for the last 20, 309. Tweedledum did nothing for the first 10, but for the last 20 years has been savings. Still only 255 has not caught up. They're in the same type of account, same interest rates. I'm not playing games with you guys that way. How about 10 more years? All the way to retirement age, which is full retirement age is now 67 for most of us all. So it's actually over, it was 33 years that Tweedledum put in, finally at the last year, right in here, caught up.
Oh, wow.
But he had to put in for 33 years to get basically the same of 10 years and stopping.
Wow.
So so what's the moral of the story?
Save money.
What's that?
Save up.
Start early,
You just-
start now, yeah.
Save up early before you go broke.
Yeah, because Tweedledee only put in 42,000 for that first 10 years, got 840,000. Tweedledum had to put in almost 200,000 of his own money to get that basically the same amount. But here's the big question. Start early, but also keep savings. So this is what would have happened had Tweedledee kept on saving. So that first 10 years. Notice he's now got 1.6 million, almost 1.7 million. He got twice as much money. So that first 10 years ended up, everything else was the same after that. But by starting 10 years earlier, twice as much money at retirement. 1.6 million, 1.7 million versus 850,000. Okay. So yes, if we start earlier, and again, that was one of the things. I guess my wife was saving. I didn't save my first 10 years. I was more like Tweedledum, and I would have been fine but then we got divorced, and she took her money, and I took mine, and I had no money. So, but that's sometimes you get what happens to you. Okay, so start early. The other part of this is when you invest with through your employer, oftentimes they have matching dollars. So sometimes they have 401ks, retirement plans. You put it away, your employer will put money. That's like 100% free money. Yes, sir.
One question I have is for the savings. So do you recommend having two savings accounts, and one is where you can pull money out of, and then
Yeah.
the other one is just one that you don't touch, period?
Yeah. You have two different, you have long-term goals, retirement, that you don't touch. Okay.
Retirement. So when do
Or-
you think we should open a retirement account?
When do you think it should be a good time?
Whenever you stop working.
Yes, today. Yesterday would have been good, yeah. So it's never too
Okay.
soon, yeah.
Because I already have a job, so I'm thinking like.
Exactly. Whatever, and again, 10%, a lot of time you won't miss that. But if you spend it and don't start it, it also doesn't grow very quickly in the beginning. So that's one of the things you should have to say. But yeah, if you have a job, think about putting 10%. Whatever you got, put it away. And again, it can be substantial. And the homework problems we're going to do, we'll see that basically the income at retirement is twice as much over for Tweedledee than Tweedledum. And that was just by starting 10 years earlier, right? And that's all we got. So, but if you're interested, we can talk more about those kind of things. What we're going to do now is get into the quizzes, so then we can start, because that's part of it. We'll see how the different interest rate makes it.
Is this kind of what we start to see how we actually put it into the financial calculator?
Yes, exactly. So we're going to go back and forth here. So that's chapter 5. And we're going to do the homework quiz. And again, your numbers, when you go to do it, they're
Yeah, like same problem layout, just different values.
right. Let's make it a little bit bigger. There we go. So, actually, I can close this one. Oh, let me do something. We need our simple interest calculator. I think this is the one yeah, this one's the one I like to use. So I'll put this link into Canvas as well. So
Calculator soup.
yeah, calculator soup. I don't know that it's you can download it as an app, but it does work online, and it saves us from having to do algebra. External link. So I'll label that simple interest calculator. Versus the financial calculator. And again, when you're doing the homework, I encourage you kind of to have both of them open.
Made a separate tab just for it. So.
Yeah, so we'll go back and forth. Here we go. Okay, see that okay? So, what we look at, and actually, let's see if I can pull this down, and then what I like to do with these is actually resize the windows.
This is why we need the laptop, so I don't have to keep like swap
Oh, yeah.
tabs and apps just to,
Exactly.
especially with something like this because it makes it kind of just fickle.
So come over here. So Joy invests 8,000. Is that a present value or a future value?
Present.
Present, because she invested now, so it's, yeah, kind of present term. So that's a principal, so we come over to our calculator, we're gonna put 8,000 in there. At 5%, simple interest, so that's, the simple interest tells us we use the simple interest calculator. Rate, and the cool part is we don't have to turn it to a decimal. We put it in, 5% is just put in as 5.
And then time 14.
And 14 years, so that's time in years. And this is kind of nice. You could change it if it was in months, you could do that. And then we just need to calculate. Oh, and then scroll. And it tells us that in 14 years with simple interest, Joy will have 13,600. They also do this nice little calculation that she earned 5,600 in interest. So sometimes the questions will ask how much interest did she earn, which actually this one did. How much interest is earned over the 14-year period? So that's been done for us. We didn't have to do we didn't have to say, oh, she put in 8,000, subtract, and we got this. It does it for us. And again, when you're financial planning, you want to focus on the planning part more than anything else. So 5,600, we enter that, and then it was 3,000 or 13,006. How much is in the account? 13,600. Check our answers. It's good.
Huh?
So they just have that simple interest calculator.
So I put in the values that were in this one.
Mm-hmm.
It's 13,000 at 4% for 19 years. But in the what you said, we input both those, said it was wrong.
Okay.
So wait.
Make sure. So notice.
So wait. So wait, wait, oh, yeah, the other way around.
Okay.
It's the first question I got a 0.
Yeah, you can redo it.
I can?
Yeah. So the other thing we'll see is that the simple interest calculator, we can solve for principal, because sometimes they'll say how you want to save this much, how much do you need to put in, the rate or the time period. Typically it's put in the principal, this, that, and it will calculate it. But let's go to the next one. Oops. I want to go here. Just 5 questions. Joy wants to invest $6,600 in a savings account. Determine the interest rate required for Joy's investment to double in value in 14 years. Okay, so again, all the information's here, but what's the question asking us?
The percent.
The percent, determine the interest rate. Okay, yes, sir. Daniel.
Oh, no, I'm just stretching.
Okay. So they want us to find out the interest rate, so we click here and we change it over to find the rate. And notice everything else changes. So total, the principal, Joy wants to invest $6,600, so that's the principal. She wants it to double. So in the future value, right, the total that she's going to have is double that amount. How much is that? 6,600 times 2.
13,200.
Very good. How much time is she going to let it sit? This one says 14 years. And then we just calculate, because we've got everything filled in that we can fill in, and it says that she needs to get an interest rate of 7.1429, and they said round to the nearest 0.1%. So notice it's giving us as a percentage already, so 7.1. Is that okay? And again, you'll kind of practice. But what you're going to see is that each of these questions, we just got these calculated. We just got to get the stuff in the right place. When you make if you don't get it right, then take a look at where everything is. And we'll see when we get to the time TVM solver. Because I think there might be one more simple interest, and then the rest will, okay, here we go, compounded. So $2,300 is invested in an account for 10 years. Find the value of the investment at the end of 10 years if the interest is compounded at these various rates. Okay, so now we get to start using this calculator, the TVM calculator. This has got compound interest. And again, I'll kind of shrink it down here. And then we can go back and forth. So $2,300 is invested. What kind of number is that? Present value. For 10 years, so periods. Now sometimes we'll talk about this, but if we actually we have to talk about it now.
Annually?
Annually, yes. Because the first is going to be compounded annually. We're going to see how this period's change, but we'll do that. Are there any payments? It says find the value of the investment at the end of 10 years if interest is. So there's no payments, so we put in a 0 since they didn't mention that. We want to know what the future value is, and they give us an interest rate of 3.8%. So we just put in 3.8. We do not have to turn it into a decimal. Notice there's one blank missing. What do we do with that? Click on the button. Future value. Oh no, how could she have negative money? What does that negative mean? It's not that she lost the money.
That's how much she invested,
It's,
how much interest she's earned?
it's a total that came back to her.
Okay.
So the negative just is a different direction. So she invested the money, she actually had to give it to somebody or buy something, right? So it went away from her, this money's coming back. So the negative is, one of these things has to be negative, which just means direction. What I would do, if you remember, is I would look at the 2,300 as being the negative, because you have to go invest it. It goes away from you. And now when we do that, notice this is now a positive value. In the answer, either way, we're going to enter a positive number, but the calculator keeps track of it, of which way is the money going.
So
Okay.
this is how much they compounded, right?
Right. And this is what they, yes, if it's compounded annually, she'll get back $3,339.65. So that's what we enter, $3,339.65. Okay. What we're going to see is that when it's compounded more often, she's going to actually end up with a little bit more. So go to my window, financial calculator, and watch what's going to happen. If we compound semi-annually, how many times a year is that? 2 times a year. So watch what's going to happen. To do that, we go to our compounding, we say semi-annual, but we're not done yet.
Let's change the period number, right?
Right. It's 10 years times 2, because each year is going to be 2. So it's actually, we're going to change our periods
20?
to 20. Periods is the number of years times how often it's compounded. Okay. So that's a big deal that we're going to do.
Hit FB again.
And then now, yeah, the only thing we have, because it's the same interest rate, right? But notice she ends up with a little bit more money. $20 more, something like that. $10, $11, $12. Oops. And the other thing you can do with this is you can, if you shorten this side, now you can have them side by side, copy and paste if you want, whatever, not that much more. Okay, quarterly, that's going to be, so I come down here, say quarterly, that's 4 times a year. So how many, what's my period's going to be? 40, 10 times 4, right? Good. So now you're getting on. And then future value, no, a little bit more money. And all that's happening is they're paying us our interest sooner. And so then that becomes our money, and now we're getting interest on top of that interest.
And then comes monthly.
Then monthly, so we just change this to monthly. But now what's our time? 10 times 12, right? This becomes 120. So we got to keep that period as always years times compounding. 336.61, right? So it's going up, but remember there's sort of a limiting. After this time, it's not going to get too much bigger. 3361.24, and just be, oh, thank you. It's real tedious, but you got $4 more. Make sure you're entering the numbers, the cents. And then daily.
That's either, right again, it's 365 days in a year.
Yep, 365 days in a year. And yeah, you have to ask that because in some business calculations, they use 360 instead of 360, but there's 365.
Yeah, because it says ignore leap years.
Yeah.
Because leap years always shave off 5 days off the year, right? I mean, is it more or less?
What?
Is it more or less days than that?
You get one more day in a leap year. 366 every 4 years. So some people say, okay, then I'll do 365.24. But anyway, and you'll see you get a little bit more, maybe about $2 more.
1 million. That's 250. Well, I was calculating my own. I was voicing my head, but wait, how is that? And it might end up in the billions.
You might have changed something else. Make sure you're doing your periods right. So 365 times 10 is,
Oh, oops, I forgot to set it to daily.
yeah, and then change it to, yeah, because otherwise,
There.
if you don't change that, then that was a lot of years. And you see, if you would have had your great grandparents, if they would have just put $10 away for you and they let it grow for 200 years, you'd be very wealthy. So think about that. Maybe you should do that for your grandkids or for your kids. Give them $10. 200 years from now, it'll be worth a lot of money. All right, here we go.
So you need to deposit in an account now in order to have $6,000 in the account in 15 years.
Yeah.
So, but this one we're finding the present value. right?
Exactly. So I always, come here and let's
So again, plug
delete it.
everything in and make that.
Yeah, we know our future value, whatever that is. In this case, it's 5,000. So they tell us our future value, and that's what. And again, that's going to be positive. We're going to have it invested for 5 years.
Oh, one question I have is, so what calculator do you use again for the first two
The
questions?
simple interest
Oh,
calculator.
okay.
So the question will have to say it paid simple interest, then you know to use a
Oh,
simple.
okay.
If it doesn't say simple interest, then we use this
So
calculator
keep
for
it
everything
at
else.
zero because there's nothing there.
Right.
So then after putting in all that in, present value.
And 7%, but it's compounded quarterly, so now I gotta come back here, gotta change this to quarterly, and I put in 5 years, but I need to put in 5 times 4, right? For my periods needs to be 20. So that's typically where the mistakes get made is entering the number of periods.
So yours was 5 years?
Mine was 5 years.
Because mine was 15, so that would be.
15 times 4, if it's quarterly. So they change all of these different things. So again, how is it being compounded? Your periods is always years times number of, and so again, it's negative, but that's what I have to invest. So we don't want to put a negative number in here, but we tell them $3,534.12. We deposit that 7%, 5 years, we will have 5,000. Okay, but you see how powerful this is. It can do all these calculations. We are doing the math, but it's all those formulas are behind there into the calculator. And if you download it to your phone, if you ever, especially when we borrow money, you can check them. You go to buy a car, they're going to want to finance it for you, and they're not always straightforward with you. They're trying to. When you buy a car, where do you think they make the money? It's not on selling the car. It's the interest. It's in the finance room. Because we had two, my boss used to be a used car salesman, so he picked up 2 accounts, but that's what he says is the money is made in the financing. Yes.
Sorry, how do you get 20 in the periods?
Oh, 20 in the periods, that was 5 years times 4 for quarterlies 4. Yeah. So yeah, watch how they're having it compounded. That's an important thing, is how often are they compounding? Because this 20, if it was compounded annually, that would be 20 years of compounding, and actually you'd get much bigger. So these and again, those are the easiest ones. I forget to change them myself at times. So I think we just have one more question.
Yep.
And this one is getting at, we're going to actually maybe have to use a formula, but I think we could also, we'll see. Let's see. A bank features a savings account that has an annual percentage rate of 2.8% with interest compounded monthly. Nick deposits $7,000 into the account. So the first question, how much money will Nick have in the account in 1 year? So I guess we could do that first, right? So Nick, what's the present value? 7,000. And remember, I'm going to enter it as negative 7,000 because that's money that Nick has to give up. He has to give it to somebody. It's still his money, but and it's 2.8%. So percentage rate. How is it being compounded? Monthly. So we got to choose that one. There's no payment, so we leave that at 0. How many periods are there if he leaves it on deposit for 1 year.
That's 12.
12 times 1, right, good. And so then we can calculate the future value by just clicking on it. Notice I haven't cleared it out, but once I click on future value, it gives it to us. And you can see it's the 7,000 plus some interest. But how much money will be in there? It gives us exactly $7,198.54.
Annual percentage yield.
Now, we remember in the slideshow I gave you a formula for that. It was, and I'm actually not going to use that formula. I'm going to show you a trickier way that we can use the calculator, but just in case, I gave you that if you had the future value divided by the present value, so we could do that, and you raise it to 1 over the number of years, which actually in this case is easy because it's just 1. And then you have to subtract 1. So you could do this, but I'm going to show you another way that we can do this. We're going to put the present value in as $1. We're going to leave all of this, and we're going to get the future value is 1.03. Now we started with $1. How much interest did we really get? 3%.
How do you get 1.03?
I put in $1 as a present value, and I clicked on future value without changing anything else. So this is telling you the effect of compounding monthly. If I was well, let me just show, we'll go ahead and do that. I think 3. The problem is if there's more decimal, nearest hundredth of a percent. Now, the thing is, we're probably going to be off because we don't have enough decimal places, right? This thing doesn't give us more, and there is no setting to give us more decimal places. So let's see if but it should be about 3%. So what is it? Future value was $7,198.54. I put in 7,000, or they put in 7,000. So if we divide this, since it was only for 1 year, it's 1 over 1, so the 1 power, and then we subtract 1. Let's try that calculation and see what we get.
Yeah, so you're just going through the question to check your answer? Basically check the answer?
Well, more than that, I was realizing that when it says 0.03, it's not giving me enough decimal places, and the question's asking for the percent to the hundredth decimal, or to the nearest hundredth. So I really need to put 2.84, right? Rounding that 3 up, because if I turn this into a percentage, it's going to be 2.836. So to the nearest hundredth, I need to put in 2.83.
So you did 7,198, that number divided by 7,000, and then what'd you do with the exponent?
The exponent is I didn't actually do it because it's to the first power, which means you don't have to do anything.
Okay, so divide and
then subtract 1,
Okay.
and then you get just the decimal part. Again, if you want to turn it to a percentage, then I guess we would multiply by 100, and then you'll see it's 2.836. And since they wanted to the hundredth place, which is 2 decimal places,
It'll be
2.84, right?
So is that the actual answer?
That's the actual answer. If I would have put in 3%, that was rounded to the nearest percent, right? So, and it's just that calculator, that's as best as it could do. What was it, 0.8? for. Okay, so yeah, doing it monthly, we get a little bit better interest. Let's check our answers, and it worked.
Alright.
All right. So we try to, now with the TI 84 calculator, it actually will calculate to better decimal places. So the other thing you could have done, I'll show you one more thing, is you could have put that you put 7,000 in. We know we got a future value of $7,198.54. What we're gonna do is we're gonna treat that as if it was done annually, because that's really what it is. And then we're gonna go on the rate, and watch, this is gonna tell us that the rate is 2.83.
So, yeah.
So it's kind of just the effect of the compounding.
Keep that one up there.
Sure, sure. So it's another way that you can kind of do it.
Alright.
But notice I have to have my negatives here. If these were both positive, it wouldn't know how to do it. When money always has a direction as well. So when I always look at it, if it goes away from me, it's negative. When it comes back to me, it's positive. If you could look at it the other way, it'll still work, but you have to have one direction is positive, the other direction's negative. And that's what that negative's there for. And you'll see that. And in the homework, you'll get to do a lot of different calculations. What the goal is to get you a feel for how much money you end up saving, how does the interest rate itself make a difference? How much does the time make a difference? But going through each of them, you'll be able to do it all with the calculators.
Sounds good.
And you'll be perfectly set. When we get to loans, all we do is the money's going in a different direction. We get, we borrow the money, so we get the money first, and then we have to pay it back over time. So, we're gonna use these exact same tools, and the mathematics of the money works the same. It's just going in a different direction.
Gotcha.
And everything we said, so we said, what's the best thing for savings? What do you want to make the longest or the biggest? The time, right? Because that was up in the exponent. So when you borrow money, what do you want to do with time? You want to pay it back as quick as you can, because the longer it takes you to pay back, the more the borrower's getting. So loans work the opposite of savings for us. So when, in savings, you want high interest, you want long time. When you borrow money, you want low interest, and you want to pay it back as quickly as possible. All right. And we got all the recording done.
Great. So